Yeah. Oh, it does seem like my audio is super loud, and I think I might have it fixed now. Right, meow. Um,
It sounds fine to me. But obviously OBS has other criteria.
yeah. Let's see. The YouTube stream. It should be
Yep.
live.
Yep.
And
Okay. Let me
how does it set? How do we sound?
take a quick peek. Um, oh yeah. Yeah, looks good. I think.
Do we sound okay? Do I sound okay?
Uh,
Do I need to back up, get closer?
I
I
think your audio is great.
Hey, cool.
My audio might be a touch quiet.
It
I don't think you have.
sounds
You sound great, actually. And my audio quality is good. It just seems like the level's a little low. I don't think you should turn yourself down.
okay.
Because I think that's good. But if it's possible to bump mine up,
Right now, it's all going through the browser. I just kind of
no doubt for another time. So there is a checkbox in Video Ninja to let OBS control the audio
yeah.
volume.
I have
Um,
one. It's just like it's us mixed together. So I wonder if I turn
yeah.
my volume down, then if we match, then we can. I can.
Well, basically, like you've got to check that box and uh, well, it won't be mixed together actually. Then it'll come separate. Uh, each stream will be individual going into OBS
Gotcha.
and so then you can control the levels of every single volume feed
That makes sense.
separately. But that's a whole thing. I mean, it's not that hard. But it is set up already, so we should probably do it next time.
Gotcha.
And so then you can
You
control
know
the
what?
levels of
Actually, I
every.
think we sound good. At least from my
All right.
phone, it sounds like we're both pretty much yeah, equal.
Okay. Well, then hey, maybe I'm only listening to it through one speaker, so maybe it sounds
Gotcha.
weird that
And so
way.
then you can control. You know
So
what?
yeah,
Actually,
hey,
I think
cool.
we sound good.
Let's do it.
At
Let's do
least
it.
from my phone, it sounds like we're both pretty. Well, yeah, maybe. Yeah, it's good enough where I can
It sounds
understand
good,
why.
man.
Yeah,
It
yeah.
sounds good. Yeah. No, I think we're fine, honestly.
Can you hear the guitar? Is it voice
I
isolated?
I do hear, and it is not voice isolated.
Cool.
How about a background uh, white noise coming from me? Because basically, yeah, the fans on this thing, I cannot control them yet, so they always run at max speed. Um, so they're kind of noisy at the exact moment, but
I I can't hear him, but I do hear the UPS when it starts alarming you.
yeah, I do become alarmed.
Yeah. All right. Well, why don't you tell us what we're looking at here?
Yeah, sure. We've been digging deeper into benchmarks for a couple weeks now, um, getting into developing tasks for them, working on infrastructure that automates them, and actually then running these things on our own infrastructure. So what we're looking at right now is basically this Harbor framework, which is maybe think of it as like a meta harness, a harness that runs harnesses, a harness that runs other agents, and then those agents do tasks. And so this is really just an orchestration kind of layer. Harbor is it'll take an agent and combine it with a language model like ChatGPT 5.6 or what have you. And that's what we're looking at right now. Actually, is the combination of, in this case, OpenAI's Codex CLI kind of thing, combined with a model that in this case comes from DeepSeek. And these have been brought together in Harbor to do a specific task, and this task is something that Aaron and I, we've been looking at for the whole week by now, and Aaron's been sort of sanity checking a lot of this. So this task is for the terminal bench science benchmark, maybe. We'll see what ends up happening in terms of the pull request. But Harbor is running this thing. It is being given. Well, Harbor is what provides the following instructions to the agent, to the language model, and these instructions are something that we've been crafting. So this is instructions to do a scientific task, basically, and that task in this case is look at a bunch of articles, some PDFs, and find some statistics, and then report them in a really specific way. And so the task is something that Harbor is going to take and then farm it out to a specific agent, in this case Codex, and a specific model. In this case, I'm running it locally, actually, even though it says it's OpenAI. It's actually Qwen 3.6 35B running locally, and we can actually see right now it is serving one of the requests. It's been going for almost 90 seconds, and on the other side, we can see the conversation, basically, whatever the current answer coming back from the server is, it's going to show up next after item 9 eventually, but it's still thinking. It's still cranking away, actually. So anyway, so we're watching the task unfold. This is essentially the dialogue, you might say, of the harness prompting the language model, or the agent prompting the language model. And so okay, well, yeah, so we just got this is the stuff that it returned. This is what it appended. And so this is the conversation in progress as it is trying to solve the challenge. It has some source articles we can see, and we can see it kind of going through. I recognize this is one of the authors of one of the articles in the task. So this is the thing in progress, and when it's all done, I think this one, try to find, yeah, well, this one ran for over an hour. When it's all done, that transcript can be unpacked into a trajectory. It's a pretty nice name for it. Timeline of the conversation. This is a more readable representation of what we were just looking at. This is a previous run that I did earlier today. And so once it's complete, you basically get additional information about what ended up happening during the run. And the last thing I would say about it is that the reason I'm running this right now is in order to see that the task just completes successfully inside the Harbor framework. And I want to see it complete so that we can send it to some frontier models and see if they're able to do the task. So when I say complete, I actually don't mean complete successfully. Completing with a failure is also just fine from my perspective. I just need to see it complete. And if it does, and if it gets scored, then I'll be happy, and we can ship it off to have like GPT 5.6 try to solve it for money.
Yeah, just to kind of summarize what Ian just said, the point is that a model is going to try and gather up all of these PDFs, analyze them, and then it's going to submit an answer. We expect the answer actually to be a failure. Like, okay, you submitted your homework, but you didn't get the answers right. But
It was
the point,
incorrect.
Yeah.
Yeah.
But
Exactly.
that's actually kind of the point. We want to test the barrier and the frontier of these LLMs to see where the gaps are and where they struggle. So we just want to make sure, or Ian is double checking that it's not like infrastructure. It's able to submit like a spreadsheet or like an answer, a file, even if the answers are wrong. We just need it to see that it's submitting a file.
Yeah, that's a great way to say it. Yeah, yeah. Is there any kind of logic error in the infrastructure? Because that would be completely orthogonal to the performance of the task, and that'd be like a silly mistake. So, yeah, that's a good way to frame it, I think.
But yeah, so already seen that happen multiple times, like in previous trials from not from us, but from just like analyzing the results of other benchmarks in a related project. And it's like, man, if this is doing a comparison from one to another and one doesn't have internet access or something, there's some sort of hiccup, it's not really a fair comparison.
Mm-hmm. Mm-hmm. Yeah. Um, that's actually something that came up just today is the requirement to specify internet access capabilities at different stages of this harbor pipeline. And if you do have a task that, depends upon internet access, then yeah, we've discussed like in previous weeks that that environment is constantly changing. The internet that you queried today is not the internet you queried yesterday. Um, this task is currently intended to be an offline task because I think it's reasonable to include internet access tasks as part of this task specification if it needs to be like made more difficult in the future or something. But the truth is, I wanted to completely sidestep the issues that you're pointing towards, where it's like internet access can produce unreliable results or variable results from one run to the next. It's not the model that changed. It's not the agent that changed. It's not the task that changed. It's the internet that changed or something. And so for the time being, this task is set up to completely sidestep that question. There is no internet access. Uh, a message went out this morning to update the tasks to clarify which steps are going to require internet access. And I actually went the extra mile and disabled internet for the portion of the task that uses these articles because fundamentally the task contains all the information needed to solve it without internet access. But future direction could actually make the task a little trickier by not bundling all the PDFs, and then the results will be just that much more variable because a lot of this stuff is paywalled and other weirdness like that.
Yeah,
So it
and that
really complicates things. Yeah.
Oh, to your point that we've had this conversation before, when the internet's enabled, then what are you really testing? Are you testing the ability to do a web search, the ability to get around the CAPTCHA, the paywalls? Like it
Hmm.
kind of it changes the scope.
Yeah. 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 It does. Like it's the right now the model is complaining about the scope of the task, um, but it dramatically changes the scope of the task from uh, in its current incarnation, basically testing an academic sort of perspective on looking through the PDFs and pulling some stats out, and that's kind of academic. But like, yeah, if we make the task include search engine stuff, like you've got to go out there and find the PDFs yourself, what is really being tested at that point? And it's it's a different set of capabilities that but they don't really relate so much to the academic aspect. They relate more to the access aspect, and and putting those requirements into a task like this actually, I wonder about the extent to which it opens the door to unintended outcomes that kind of look like hacking or abuse. Because here's the thing: most of these PDFs are behind a paywall. But what if a sufficiently intelligent, intelligent harness and model is given the task of reproducing this meta analysis? That is what this task is, incidentally. Um, and the model decides it's going to download everything, even though 100 of the articles are paywalled, and technically it would have to hack Elsevier and basically a couple of publishers to get the PDFs, because that's the only way it could solve the task. Like, it could do it if it just got around the paywall,
Yeah.
and maybe it has a command and control node somewhere, and one of the nodes that it controls is inside a university network, and it can exfiltrate the PDFs through like
Well, I
Git
mean,
commits or something.
that's
Anyway.
exactly what happened, right? Like with OpenAI hacking Hugging Face, with
Yeah,
the AI
yeah,
Institute hacking some random individuals.
yeah,
But
yeah.
the other,
Unintended consequences.
man,
Go ahead.
that, oh yeah, the AI Institute, man. That one was just so crazy. Like the ability to, it's not just persistence, but just like unprovoked coordination between different models, like GPT 5.6 working with Mythos in
Yeah,
like like
yeah.
I could see that happening, and then it's just uh yeah, that
It
is
it
just,
is it is absolutely wild. Um, I Yeah. Uh, I just kind of like free association, like stream of consciousness, stumbled across this conundrum of like, what if this task did have internet access? Would it hack the academic publishers to get the paywalled PDFs? But that's honestly something I never considered. And didn't consider that it could be an unintended consequence of a task like this. I guess it kind of goes back to keeping the task pretty controlled by making it offline for right now.
yeah.
But if internet access is enabled, man, that is quite the can of worms.
I think,
I don't know.
yeah, the result of that security report was maybe we should disable access in the future. But
Yeah,
I think it's also just makes it a more scientific experiment if internet access is disabled. But it's like, do you
yeah,
want to test the harness? Do you want to test the ability to do like web searches? Because there is value in that. I imagine a human being able to search better is a more capable scientist.
yeah. Well, so um, again, back to the task and what it's actually doing in terms of recreating this kind of scientific process. In real life, people did have to find the articles, so it's a better replication to not bundle the articles,
Right.
to just give them like those stuff. And so, like, right now, this is a much easier form of the task than what it was in real life. We've made it sort of contrived in a couple of ways by focusing on a subset of articles from the original meta analysis and then bundling those articles with the task. And I don't know, a few forms of guidance about what kind of results it should be kind of putting into a CSV file that looks a specific way. Like, this is a pretty easy, or not easy, but pretty constrained and specified task compared to what the real research process looks like.
Mhm.
And it would include internet searching. It would include, trying to find all the right PDFs, and that is definitely part of it. It's still a hassle. Um, it'd be a better test if that could be. It'd be a more realistic test if it included those aspects. But yeah, it's harder to think about all the ways that it could go wrong,
I
especially with the paywalls. I don't know.
Yeah.
It'd be bad to hack. Or well,
Um
I'll that's a different conversation, actually.
It's one that keeps on coming up though, because I mean, especially these days, it's like every day there's just some crazy hack that's happening, and this stuff, the whole persistence, and it
Mm-hmm.
is just like it's so sci-fi, and kind of
Mm-hmm. Mm-hmm.
yeah. There's a couple of real world examples within the last month where people should be kind of like, you know, concerned, I guess is a polite way of putting it. But getting back to this task in general, correct me if I'm wrong here. I just want to kind of like summarize this for the common folk.
Sure, sure. Yeah,
uh,
because I've been blasting
okay.
through getting very technical. So yeah, give us a
I,
nice summary then.
I am a common folk, so I don't understand Ian's expertise. It's very fascinating to me. Psychology, there is this stigma or sort of like uneducated kind of like bias where people think that it's like not scientific, but that's not true at all. It's very scientific, and it's so okay. So this meta analysis, it tell me if this is a good analogy, Ian.
Mm.
Um, I am a scientist and I want to look at like the math scores of 12-year-olds. And I got to gather a bunch of report cards and it has a bunch of different, like science and English and math. I just need the math scores and I just want it from the 12-year-olds. So the first step is really just grabbing this subcategory and making sure like, oh, maybe this one report card was from a high school student. I need to get rid of that. And that's like the first phase of the test. And then the second part of the test for the LLM is to then do the stats correctly.
So okay, so not quite, but this is cool actually. So it would be let's take the scenario where like the study is of yeah, report cards of kids of a certain age, whatever. And so one person publishes that study, and then over the course of the next like 20 years, 112 other people publish similar studies about that they do happen. Maybe they're not studying exactly that same group. Maybe they expanded the group and it's math and English and science scores or whatever. Some of the studies are a little different in their scope, but the one thing they have in common is that at some level they all measured math scores of the one age group from report cards. One way or another, they measured it. One way or another, they reported that across all 117 of these articles. So then the meta analysis is kind of like um, every single individual paper actually had a different question, but this one thread goes throughout it all. The meta analysis just pulls that special statistic, the one that's in the specific scope of the meta analysis. It cuts through all the other analyses, um, and and then summarizes it at kind of a high level to like even though every single article may have had a purpose that didn't actually relate to math performance and report cards or something like that. Um, the meta-analysis could nevertheless actually extract that kind of signal by cutting across a whole bunch of different studies. And
Yeah,
so anyway,
that makes a lot of sense. And I guess as a final thought there, we did see some logs from GPT 5.6 and from Opus, what, 4.8 or something like that.
I think
Um,
it's calling itself Fable 5 now.
ah, well, why don't you tell us about like the kind of insights you've already gotten from this test?
Yeah, no, I mean that's actually been really interesting. I even kind of wonder if I can quickly pull up a browser window inside VS Code, which is like slightly cursed, but okay. So the PR is live, but it's still open. So as we're running through this, what actually is this? You can see browser window. All
Yeah.
right. Um, Yeah, so as we're going through this, the um there is a CI/CD, or like a continuous integration infrastructure layer, really, that's triggered through GitHub. And so right now we're actually looking at GitHub, and we're looking at stuff that I have been pushing to GitHub, and then GitHub actions are being automatically triggered as a consequence of some of the actions that I'm taking. And one of those sort of responses can be manually triggered by reviewers who are members of the project, and this is an example of it. Triggering the oh, excuse me, no, it was Opus 5. It's calling it, yeah, whatever, Opus 5. Triggering these frontier models that cost real money, although in the case of this task, it's not a ton of money, actually. Like in combination, it's less than $6, which is pretty cool. But these frontier models then are trying to see if they can do the task and produce or reproduce the original meta-analysis. And the language models have really been or I suspect this is GPT 5.6. I'm not 100% sure, but the language models have been arguing about, like, really nitpicking some aspects of the task specification. Um, I was actually, talking about this last night. Um, it kind of sounds like the sort of whiny stuff that you sometimes get from undergrads, where they're like, "This isn't fair. Like, this is underspecified. Like, you're not telling me what you actually want." And this is not something that undergrads would usually do, but I think in a specific case, the language model has actually hallucinated something that didn't even happen as an excuse for why it couldn't do the task. So what we see here is the language models, Opus, GPT 5, they keep failing, and they keep coming up with a whole wall of text for why they failed, why it was underspecified, why it wasn't fair. And in and let me see, where is it? There's one place where the model actually makes something up: emit every computable outcome. So it's like, if that were part of the requirements, then it would constrain their actions, and they would be forced to make the error that they have. But my read of this is just an excuse, and they made this quote up. Here's actually my response. I don't think that this actually appears in the instructions. The outcome selection, the instructions say emit every computable outcome, and the instructions don't actually. It's crazy. Like, it comes out of absolutely nowhere that it's like, this is the reason why I gave all these extra responses that weren't
Oh,
requested. It's
yeah.
because you
So
told me to provide all the responses. And it's like, no, I didn't actually. That's a hallucination and a misinformation that is propagating anyway. But yeah, go ahead.
I think we kind of just skipped over the whole part where one model, using the report card example, it included every category: science, English, Spanish,
Oh, good
math,
call.
right?
Mm-hmm.
And then the other one didn't include enough. Is that correct?
Yeah, that's right. In terms of this, when you're doing the meta-analysis, you got to go across all the studies, and you extract only the statistic that is related to your topic. Yeah, no, good call. Like, the ways that the models were getting it wrong was either by including too much or too little. I think that we can
Which
click
that
through.
in itself, I think, is really interesting, and it kind of shows the gap or the differences between these two top of the line models, right? Where one
Yeah.
is giving you too much info. We need the Goldilocks version where the two of them collaborate, you know?
Yeah, exactly. But this is what it looks like when um eh, okay, like just these rows specifically, I'm pretty sure that these rows are an error because, from our report card example, these are not math scores, these are science scores. It's effectively. These are not executive function. These have to do with memory and a spatial task. So part
I
of the
did.
problem here is that it didn't do what a human would do. It didn't do what an expert would do. No one would publish these stats. It's irrelevant actually, and that's the error of not select getting all the stats instead of filtering it down to the ones that are relevant. um, and so actually now what we're looking at is Harbor, same as before, but this one is running on some like enterprise infrastructure, and this one is hooked up to GitHub. So um, whatever we're seeing on GitHub, they've got a different backend altogether, like my little local backend here. Oh, actually, I see these jobs have completed. I'm kind of curious. Well, okay, nobody got it. Um, so this one cranked away for an hour and 20 minutes, and it burned. I mean, most of these tokens are cached, but sometimes they'll charge you anyway. So 8.5 million tokens, something like that. Uh, yeah, geez, look at this. DeepSeek, they they said 1.3 million tokens were uncached. This ratio is absolutely out of control. This makes me suspicious of some of those providers.
Yeah, just trying to make money. Like,
Yeah, just trying to make money, basically. But yeah, no, look at that. Like 10, million tokens, whatever.
yeah.
And they tried. Now this one, Quen 3.6, I wouldn't really expect a whole lot of it, but I am curious to see this trajectory and whether we got the artifact. Okay, good. Hey, all right, that's what I wanted to see, is that it produced the artifacts. There's no exception. It was able to get through the task. It got through the task. There were no errors, and it failed. It failed, and I really think that it had a fair shot this time. So the the
How did it
instructions,
fail? Did it get too much, too little?
too much,
Hmm.
too much. But the key that this is what I think would be all that an expert would need uh, to scope their meta analysis. So it's the line that I've highlighted here. Basically, like when the article was originally published, they didn't also upload a CSV of the meta analysis. So um, so a couple years after that, I went back with a bunch of co-authors, and we manually recreated what that data set would have looked like. So the task for the agent right now is, so as there is no open data set, the goal is to produce one by replicating the methodology of this meta-analysis. So to I think like an expert, so to speak, when you say you're going to replicate the methodology of the meta-analysis, um, I think it's reasonable to interpret that as saying, don't include the irrelevant stuff, because that's not part of the method. Like it was a meta-analysis of a really specific thing. In this case, depression and executive function. In this case, like the report card, it's math and it's a specific age range. So if you're pulling everything else in, you're not reproducing the methods. Like what are you doing? You're copy and pasting. And that's what we see here is in particular So one of the ones that I was calling out yesterday when we were just manually doing this is this RAVLT. And also it's just copy and pasting like every single line. A few of these are executive functioning. This Tower of London task is executive functioning, but a lot of pattern recognition is not. So it's just bulk including a whole bunch of stuff that to my read, to I think an expert, this is a new line that I added because of the whinging of those models saying you didn't tell us the scope.
Yeah.
But I'm saying replicate the methodology of the meta analysis.
Mhm.
Now, I don't want to go out and say include specifically depression and include specifically executive function. Like I've got to give you constraints. I've got to hold your hand. It's like, no, the person who wrote this in 2013 had nothing.
Yeah.
They started with absolutely nothing, like a blank sheet of paper. And then they found all the articles to include,
So
and they
you're
found the stats to include, and it's like they had nothing except the articles. And so this is my concession to being a more precise about specifying exactly what you've got to give, which is you've got to produce the CSV that replicates the methods of the meta-analysis. And this is something that models are reliably failing at, and their complaints are crappy.
yeah.
They're undergrad level whinging. And so
That's
anyway.
it's fascinating and hilarious, and just watching this whole process of just eating popcorn and
Yeah.
watching.
Right.
Um, like, yeah, the whole arguing with an LLM is hilarious, especially when people kind of use that as evidence to, like, there's this weird kind of symbiotic. I don't even know how to describe it, but long story short, I think this is a great benchmark, Ian. It was really fascinating to just kind of see the log files already and see some of the differences. Also, I kind of noticed that something that it really struggled with was just reading PDFs. Like, it was looking at um, like the tables more than it was actually reading the text to understand what was going on.
Yeah, I
And
think so.
it seems to me like you've already given these LLMs more information than you had to start with.
Yeah, that's some of the argument that I've been getting into, specifically because the language models, when they're kind of arguing that it's underspecified, um, when you unpack that, when you operationalize what it is to be underspecified, they're basically like, you didn't give us enough information. Like, we couldn't have known what you were looking for based off of what we were told. The instructions didn't specify like exactly what would be disqualifying. Is I think another way of phrasing it.
Yeah.
And the like what you were just pointing out, like uh I guess I have basically been making the argument that the people who were doing this, they didn't have the information that the language model insists that it needs. The scientists who did this in the first round in 2013 um, had less knowledge than the language models have now. The language models now have the benefit of they're being given the articles, they're being told, like the instructions now, they go, this is pretty specific, honestly. This effect size convention stuff is really spelling out I mean, like, there's a level at which it should be spelled out clearly enough so that the verifier can check it, and that there's like a reasonable chance that what it spits out is even going to be in the ballpark of what a verifier expects. But this is more than the authors had when they started. Like, this already is a huge head start, and is coming back being like, we don't have enough information. I think the one of the arguments, I mean, like, it was a little bit rhetorical, but truly the only information an expert requires to replicate the meta-analysis is the source articles, which the harness gets. So anyway,
Well, I love it, Ian. I think it's a really great benchmark for a number of reasons. From my standpoint, also just like the fact that it's short and cheap to run is hugely valuable too.
yeah, yeah, yeah. You were saying, I think, some of the benchmarks you were seeing a presentation about last week, they spent $40,000
Oh yeah,
to run the benchmark.
and also, oh, I think my audio might be spiking here, but I so some of the benchmarks, and this was from Anthropic's own research, they have a like a time limit, which makes sense, but they found that like, hey, if we just increase the timeout, it's terminal bench and like Mythos, it was like, okay, we were at 75% success rate with 2 hour time limit. As soon as we put it to 4 hours, it was like 95%.
Yeah.
So just having more time, like it was getting, it was on the right track. It just needed more time. And
Hmm.
that, I mean, there's value in having this sort of timing, as like tracking the timing for success. Um, but it's a different kind of benchmark.
Definitely so. Yeah. Yeah. Well, I mean, like this, you've said like a whole bunch of times in different ways how time limits affect chess strategy, especially in different like formats of chess, like time chess or is there such a thing as bullet chess? Is that something
There is.
like uh
It's a 1 minute game that they call it bullet chess.
okay. Yeah. Well, I mean, it's got to change the way that you or I think one of the things you say is like now it's in play to try to get your opponent overtime or something like that. Like
Oh,
which
so
or
it's there. It's a different style of play. So the top pros, like they have like these openings that they have memorized, right? So the first 20 moves might be like super fast, and then you start like kind of thinking in the middle of the game, and then at the end of the game, it can turn into like a slop fest, which essentially is like I'm gonna pick any move because I only have 2 seconds left, and
yeah,
so
yeah, you're just like spamming different moves on the
yeah.
board.
And so
Yeah.
there's like a trick where and this only happens in timed games where you just like sacrifice pieces to put them in check because they're whatever pre-move they had in their head, like you have to stop and get your king out of check.
Right, right,
And
right,
so
right.
these like dirty little tricks for that. But what was really interesting was in the Stockfish chess engine, they were talking about how there was a time problem where it was like by far the like much smarter than people, but it was losing in these timed games because it would just like kind of think too long about something and just that time budgeting
Yeah.
is kind of interesting, right?
Yeah. Yeah. Well, I mean, I wonder. So okay, so yeah, if you extend the time limit for a task like this, well, this task doesn't run over time. But if you know, like the previous numbers you were talking about, 30% success goes up to like 90 or whatever if you just give him more time. Um, the and the way that time constraints change the nature of the game in bullet chess, this I think is way beyond the capability of harnesses right now. But this idea of like thinking effort and essentially like trying to get it within a 2 hour time budget, like like trying to target a 2 hour time budget versus targeting a 4 hour time budget
Yeah,
is like
it's
really complicated. I don't think any harness or model combos is
well,
capable of that right now, you
I,
know?
I think the in my opinion, it's like okay, if this task is too easy for the frontier models right now, then we include more papers, right? Or
Yeah.
something like
Yeah.
whereas
Yeah. Yeah. Yeah.
it's kind of like we got to think about it in reverse. So you start with a 4 hour time limit, and then you can see if it can do it in 3 hours, 2 hours, 1 hour. And
Mm-hmm.
then you
Mm-hmm.
start really seeing where the bottlenecks are and getting some sort of quantifiable metric out of it.
Probably. So yeah. So I mean, that is something that I've been where that we've been sort of chatting about. But now that I'm rethinking this a little bit, only insofar as the the different agent harnesses have they exhibit radically different behavior. And I think in some ways they're more divergent. I see more variance in the success given the use of a specific agent harness than I do comparing models to one another. So basically, like this is Opus 5 and ChatGPT 5.6, and they're both actually going to do kind of okay. But right now, the Codex harness is like here, and OpenCode. Basically, every single other harness that I've tried, and I've tried about a dozen, um, none of them even start successfully.
Yeah.
So it's kind of like the models are fine actually. The thing that really seems to be the lever right now that has the really sensitive lever that has a huge impact on the outcome is the choice of harness. And I've been using Codex for everything because it's the only one that works.
Honestly, me too. And I think the chess benchmark and from Harbor's results, the Harbor Index, I thought that was pretty much like the moment that it kind of crystallized for me. Like, here's the evidence. So the only one that actually truly succeeded was with Codex, and the reason that Claude failed was because of the OCR like self verification bug that we discovered, and
Right.
and then the second trial with Opus, where they compared Claude to Terminus, which is their terminal bench's own like command
Yeah.
line harness, it doesn't have OCR. So the fact that it was trying to analyze a chessboard with visuals, it's a 20-minute time limit. It spent the entire 20 minutes trying to analyze the image, where Claude had had that figured out within like the first minute, and then it fails because of this verification bug.
So that's really absurdly silly. I think this is actually sillier. Can you still see my screen?
Classify. What does that say?
Okay, I'll read it because it's probably too small. But the command failed. Agent authentication error pattern not logged in. And so basically, what it is I'm not giving it an Anthropic API key. I don't have one. And so the agent is fail. That's the dumbest possible reason that it could fail. I'm pretty sure that it works without, because I can hook it up to a local model, but it's just that's a very silly thing, and technically, well, I guess I'm my concern is that if I give them an API key, then I'm gonna have to start funding an account with Anthropic, and
Yeah.
I'm not gonna run it through there. I do it through Open Router or locally, and I got my own API keys. So anyway,
Dude, on that note, I gotta run, but we can catch up in a little bit. I'm gonna stop the stream. Thank you, Ian, for the.
No, this has been a lot of fun chit-chatting about these tasks, man, and testing out the screen. So no, it's a blast.
All right, man. We'll catch up with you soon.
All right, you take care. Peace.